Hi, Hans here, and I have the USB-C battery pack, so we can give it a spin and see how well it works with the laptop project. At first glance, it looks like it's working great. Right? I have the machine running, it's running off this battery pack, everything looks good. However, there are some problems. First one is more of a minor annoyance. This battery pack is supposed to switch on automatically if a USB-C device is plugged into it. And well, with the power converter board and the mini-ITX motherboard in here, it doesn't. And the reason is, well, this is what I expect the reason will be, is initially there's not enough electrical load on it for it to detect that something is connected, so it doesn't switch on. That's no big deal. I can create an artificial load that can be switched in and out to initially switch it on. And then I don't have to push two buttons to get the machine on instead of one. Now, if that were it, that would be great, but there's more. The next problem is I assume, because this is like the USB-C, that there would be a way to read the battery pack status from the computer. Well, there isn't. And if I think about it, this battery pack is intended to be there to recharge the battery in the laptop or the battery in your phone, not to be the battery in your laptop. And so therefore, being able to read the status is not that important, and hence they didn't put it in. For me, that's kind of important though. I do want the laptop to be able to read the battery status so it knows when to save and shut down so I don't lose data. And there's no way to work around it because there's power electronics between the battery and the outputs here. Okay, I suppose you could drill holes and open this up and dig in further, but I want something that's easy to put together, so that's a no-go. Now, the next problem for me is even worse. So I have the LCD panel and controller drawing power from the old USB, the larger USB connector on this thing. With the idea is I get 60 watts output for powering the motherboard, the graphics card, the drives and everything. And then I have it up to 18 watts to drive this thing. Well, looks like everything's fine until you start running things. Let's run the cow 3D demo. So spinning cow. Oh, screen just went blank, and you occasionally get a flash where you see it and then it's gone. And if you probably can't see it from the camera, but if you pay close attention to the LCD controller's LED, it's switching on and off. So what's happening is this is drawing too much. Let's stop that. It's quite annoying. The LCD panel and controller are drawing too much power for this thing to deliver. And therefore, when it goes over, it's like right on a knife edge, I guess. And when you go slightly over, it cuts out. Now, I didn't realize it, but the way this port works is it's limited to 1.5 amps, and it has quick charge support, so you can get more power out by raising the voltage. Whereas the LCD controller needs 5 volts, so it's stuck at 5 volts, 1.5 amps. And that's not quite enough, and we're not even using the speakers yet. It also has a built-in audio amp. And this is a big deal because I kind of need, when you're dealing with battery power and things like that, there are two numbers you need to bear in mind. One is the average power usage, and that one sort of decides how long the battery works, how long the battery runs for, how much time you've got. But all of the components also have a peak usage, so peak number of watts. That includes I think the graphics card in here, its peak might be 55 watts if you really, really max it out. Now, you usually won't get there. But anyway, if I take the 60 watt output and then I drive the LCD panel and controller from that too, we're easily dropping 10 watts off the maximum power available for the rest of the machine. And so we're now getting down to like 50, 48 watts, that sort of thing. And I don't think that's enough really for the desktop hardware that's in here. Right? The laptop computers are dedicated made laptop computers. they can be designed to always work under that level. But yeah, we're dealing with desktop hardware. And I really want to have enough of a ceiling to be able to power these things, even if they max out at maximum load for just a fraction of a second. That can be enough to kill it. So I feel powering everything off the 60 watt output is not gonna. It's just not gonna work. There's not enough power delivery to be able to deal with occasional peaks. So theoretically, I could use the quick charge protocol to increase the voltage on this one, but then I have to down convert it to 5 volts and a higher current level again, and that's kind of, again, it's working around a problem that shouldn't be there. It's kind of wasteful. The other option would be to power everything off the 100 watt output, but the 100 watt output is also the 100 watt input for charging. And I don't know about you, but I don't like the idea of a laptop where I have to shut it down, or it shuts down automatically because it ran out of battery power, and then I have to plug in the charger and wait, right? Or use two separate chargers, one to run the machine while I'm waiting for the battery to charge, and one to charge the battery. Maybe you could design a power board that would be able to automatically switch so that you can charge while using the computer. But again, that's a lot of engineering effort to work around a problem that shouldn't exist. So bottom line, this battery pack was a great idea, I think, but it's not going to cut it. It's not going to work. Not suitable. It's not the end, though. I still like the idea of using a ready-made USB-C battery pack. There are a few others on the market, and I've actually contacted one company to ask if it's possible for the computer to read the battery status. I'm still waiting for a reply on them. Hopefully it'll come back positive, and then I can buy that battery pack, which is more expensive than this one. But hey, if it does everything that I need, then it's great. I'd willingly pay the extra amount. If not, I might end up going back to, well, I'll have no choice but to go back to the old micro UPS and homemade power bank, which, as I said in the previous video, is a bit concerning because it's too easy to buy batteries that are counterfeit and downright dangerous, right? Lithium-ion batteries that are poorly manufactured have a tendency to self-ignite or explode even. Anyway, I'm still hopeful that I can get a USB-C battery pack that will be able to power the laptop. I will update you later when I have something new. Until then, see you next time.